Good morning, boys and girls. Happy Tuesday. Welcome back. Today we're working on Module 16, Lesson 2, Represent Equivalent Fractions with Larger Parts. If you turn to page 425 in your book, you can follow along with us. The ICANN objective reads, I can represent a fraction with equal parts that are larger in size than the equal parts of an equivalent fraction. And boys and girls, we're building on what we started yesterday. We're looking for equivalent fractions. And if you take a look at that word equivalent, you see the word equal. So we're looking for fractions that are equal to each other. Let's start off with the build understanding. And remember, boys and girls, if I don't always do the 3 reads, when you're at home, you're doing the 3 reads with your word problems. The first read is to understand what the situation is about. The second read is to look for quantities and see what the problem is asking you to do. And then that third read is to kind of put it all together right before you solve the problem. So number 1, at soccer practice, Coach Penny draws a diagram in which she divides the field into 8 equal-sized zones. The 6 zones closest to the goal are the scoring zones. Use Coach Penny's diagram to show the areas she uses for the scoring zones. Okay, so I know this problem is talking about soccer and a soccer field, and the coach goes ahead and she splits up the field into equal-sized parts. Now, I know if they're equal-sized parts, I can use fractions to represent them. So let's read the problem again and now look at the quantities in it. At soccer practice, Coach Penny draws a diagram in which she divides the field into 8 equal-sized zones. The 6 zones closest to the goal are the scoring zones. Use Coach Penny's diagram to show the area she uses for scoring zones. So the 2 quantities that I see in my problem are the number 8, which represents how many equal-sized parts the field is broken into. And then I see 6, and that represents how many of those parts are in the scoring zone where you could score. So Coach Penny says that the 6 parts closest to the goal are scoring zones. So if we're looking at our field here, okay, we see that there's 1, 2, 3, 4, 5, 6, 7, 8 equal parts. And Coach Penny said that the 6 parts closest to the goal are scoring zones. So this part and this part, these 2 parts are the 2 parts closest to the goal, but she wants the 6 parts that are closest. 3, 4, 5, and 6. Now, those 6 parts are closest to the goals. If we had to write a fraction to represent the parts that are now shaded green, what fraction could we write? Well, let's start with the denominator. What denominator am I going to use for a shape that is divided into 8 equal parts? I'm going to use the number 8, or eighths. And how many of those parts are closest to the goal so that they're scoring zones? 6 of those parts. So 6/8 of the field are scoring zones. Let's look at the bottom. Coach Ruiz divides the same field into 4 equal-sized zones. Coach Ruiz's scoring zones are the 3 zones closest to the goal. Use Coach Ruiz's diagram to show the area he uses for the scoring zones. So I know that he's dividing this into 4 equal-sized zones. So I'm going to go ahead and divide it as evenly as possible. And I know that he's using 3 zones closest to the goal as scoring zones. So let me do some black. Okay, so now he has 3 parts closest to the goal that are scoring zones. And let's build a fraction for this one. What fraction would name the parts that are shaded in? Well, if we start with our denominator, we know that our denominator is a 4 or fourths because there's 1, 2, 3, 4 equal parts in our field. And how many of those parts are shaded in? 3. 3 of those parts are scoring zones. So let's take a look and compare our two models. When we talk about area, we talk about the space, measuring the space inside, right, with square units. So look at the area that is covered when I shade it in green. How do they compare? Right, the same amount of space is covered in Coach Penny's drawing and in Coach Ruiz's drawing. So let's look at our questions. What fraction can you write for the area of the field that Coach Penny uses for the scoring zones? Well, the fraction we wrote was 6/8. What fraction can you write to represent Coach Ruiz's scoring zone? We wrote 3/4 for Coach Ruiz. And how do the fractions compare for the area of Coach Penny and Coach Ruiz's scoring zones? Explain. Well, we see that the same amount of area is shaded in green. So we know that those two fractions are equal to each other. So we know that 6/8 and 3/4 are equal to each other. What symbol do we use in between those two numbers to show that they are equivalent? We use an equal sign. Okay. So let's go on. Oh, look at that. Our code word for today, boys and girls, is bunny, B-U-N-N-Y, and that's just going to stay up on the screen for you. Okay. And over on the right, you see our fraction strips again. And if we just want to prove that we are correct, let's take a look. Let's find the fraction strips that are eighths. And here they are. Here it is. And let's look for the fourths. And here it is. And now we would compare 3/4 and 6/8. So 3/4 and 6/8. Okay. And if I were to draw a line, I see that they are the same amount of space. Okay. And now let's look at number 2. Two relay teams race across Lomas Park. The red team divides the distance equally among 6 runners. The blue team divides the distance equally among 3 runners. Show how both teams divide the race into equal distances. Okay. So we have the red team, and they're dividing the distance equally among 6 runners. So that key word is equally, boys and girls. When we're doing fractions, we need those equal groups. And then the blue team is dividing the distance equally among 3 runners. So let's start with the red team. Show how both teams divide the race into equal distances. And they've already labeled our bar for us, so red team. And I'm going to divide this into 6 equal parts. Okay, and the blue team, I'm going to divide it into 3 equal parts. Okay. The first 4 runners for the red team and the first 2 runners for the blue team complete their parts of the race. Use the drawings to show the distance of that the team completes. So the first 4 runners for the red team, and then the first 2 runners for the blue team. So let's go ahead and shade in our models to show that. So the first 4 runners are 4 parts. So 1, 2, 3, 4. And then for the blue team, the first 2 runners, 1, 2. So if we were to write fractions for each one, let's take a look at the red team first. My denominator is going to be a 6, because there's 6 equal parts, and the first 4 runners have already done their part, so it would be 4 6. And for the blue team, my denominator is a 3, or I'm counting by thirds, because there's 3 equal parts, and there are 2 runners that have already completed their parts, so 2 thirds. So before we look at the questions on the bottom, which runner has to go a further distance? The runners on the red team or the runners on the blue team? That's right, the runners on the blue team, they each travel a bigger distance than the runners on the red team. Now, let's make a connection to what we learned about denominators and what they mean. The bigger the denominator, the smaller those parts are. So while the red team, each runner is running a smaller amount, there's a lot more of them. So on the red team, there's 4 runners who've already traveled, and on the blue team, there's 2 runners that have already traveled. But look at the distance that they've traveled. It's the same. So even though there's more parts in the red team and less parts in the blue, the distance that they've already traveled is the same amount. And now we're going to put it on a number line. So locate and draw a point to show how much of the race each team completes. Complete the number line and show the fractions. Okay, so the top part of the number line is showing sixths. What team does that refer to? The red team. Okay, and if I go ahead and I label my sixths, I have 1 6th, 2 6ths, 3 6ths, 4 6ths, 5 6ths, and 6 6ths that we know equals 1 whole. And then on the bottom, it's the blue team, and it's broken up into thirds. So 0 thirds, 1 third. Oop, what mistake did I make, boys and girls? If I keep not labeling this way, 0 thirds, 1 third, 2 thirds, 3 thirds, 4 thirds, 5 thirds, and then 3 thirds. That doesn't look right. What mistake did I make? Well, if I'm counting by thirds, I only want 3 equal parts. So I want to make sure I'm not using all of the ticks on the number line. And I also can't use the first 3, right? So I need to make sure that I'm dividing that number line into 3 equal parts. So if I have 6 parts on my number line and I only want 3, then I'm going to make ticks at every other part. Like this. And now I would have 3 equal parts. So now let's go ahead and label it 0 thirds, 1 third, 2 thirds, and then 3 thirds. Okay. The red team had 4 runners, so they are here. And the blue team had 2 runners, so they are here. So 4 6ths and 2 thirds are on the same place in the number line. So how do the fractions of the race that each team completes compare? Which team completes more of the race? Explain. Well, they both complete the same amount of the race. And the reason is because 4 6ths and 2 thirds are the same distance or an equal amount. Okay, of the same whole. And if we look over at our fraction strips, we're going to look at our thirds, and we're going to look at our sixths. And we know that it was 2 thirds, and we know that it's 4 6ths. And if we look at those amounts, we see that they are equal. So 4 6ths and 2 thirds are equal to each other, or equivalent fractions. Okay, boys and girls, it's your turn now to do the on your own. You're going to pause the video. You're going to complete numbers 3 through 6. You do not have to complete the check understanding on the previous page. And when you're ready, come back to the video and we will go over it together. All right, welcome back. Let's see how you did. To help us solve these problems, I have Tyler here.
Hello.
And Tyler, are you ready to help me?
Yes, I am.
All right, let's see your math thinking. Come on. Mrs. Ash shades half of a rectangle. Will shades 3 of 6 sections of the same size rectangle. Will says that the 3 of 6 sections he shades are equivalent to 1/2. So both rectangles have the same area shaded. Is he correct? Explain why or why not. So I see that Mrs. Ash shades half of a rectangle, and that's her model. And Will shades 3 of 6 sections, and his isn't written in a fraction. I wonder why. Okay, so both rectangles are the same size, and Will thinks that since he shaded 3 out of 6 parts, that they both have the same area shaded. Do you agree with him? Why or why not?
I agree that the rectangles are the same size, and I also agree that Will shaded 3 parts.
Okay.
But I do not agree that they have the same area because the parts are different sizes.
Which parts?
The parts Will shaded.
Good. So can I use 3/6 to represent the shaded parts on Will's rectangle?
No. Every 6 would have to be the same size part.
Very good. So boys and girls, remember when we're working with fractions, the parts all have to be the same size. So even though Will does have 1, 2, 3, 4, 5, 6 parts, and 3 of those are shaded, he does not have 3/6 shaded because the parts are different sizes. If we were to split this up a little bit better, let me just draw one underneath instead. If we were to split one up a little bit better, boys and girls, then we would be able to shade in 3/6 correctly, and that would show that it's the same area as 1/2. Okay, so Tyler, I'm going to do number 4, and then you're going to do number 5.
Okay.
So locate and draw a point on the number line for the fraction, then write the equivalent fraction. So number 4 says 6/6 equals something. So let's take a look. Our 6's are on the bottom of our number line. And I notice that I'm going to write an equivalent fraction in thirds. Okay. Now, boys and girls, I already know that 6/6 is 1/2. And I know that when you have the same numerator and the same denominator, that it equals 1/2. So if I'm looking for another fraction that equals 1/2 using a 3 in my denominator, my fraction would be 3/3. But if I didn't know that, I would be using my number line. So let's see how I'm going to divide this number line. This is a big misconception that children make, boys and girls. So here I have 6 parts. 1, 2, 3, 4, 5, 6. But the top of my number line, I only want 3 parts, 3 equal parts. So if I have 6 pieces and I want to put them into 3 groups, I'm going to make jumps that are 2 pieces each, right? So let's see. 1, 2, and 3. So if I label my number line here, 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 and here, now I have thirds or 3 equal parts. So 1/3, 2/3, and 3/3. So 3/3 and 6/6 are equivalent. They have the same amount. So Tyler, are you ready to do the next one?
Yes, I am.
All right, so 4/8, and we want to turn it into a fraction that has a 2 on the bottom. So what are those fractions called?
Halves.
Good. Okay, so 4/8 is the same thing as how many halves?
Is the same thing as 1/2.
Okay, can you use the number line to help me out? On my number line, I see that I have 8 total parts. So what can I do so that I only have 2 equal parts?
Well, if you divide 8 into 2 equal parts, that would give you 4 in each part, so
perfect. So
1/2 would go right in the
we would
middle
start
on
here,
4.
right? And then it would be 4 parts. So 1, 2, 3, 4 here. And then another 4 parts. 1, 2, 3, 4. So I'm here. So yeah, you divided your number line into 2 equal parts. So how many halves are equal to 4/8?
1/2.
1/2. Awesome. So 4/8 equals 1/2. And I'm going to pull up our fraction bars on the right just so that you can see that. Here I have 1/2 and 1/8, 4/8, and you can see that they're the same amount. I could do the same thing for my 3/3 and my 6/6. So 3/3, 3/3 and 6/6, and you see that 3/3 is 1 whole and 6/6 is 1 whole. Okay, so let's try number 6. Tim says that 2/8 of his water bottle is filled. John says that 1/4 of the bottle is filled. Are the two fractions equivalent? Draw a visual model to support your answer. So, Tyler, I see two quantities. I see 2/8 and 1/4, and I have two different models. So how many parts am I going to break up each model into?
So for Tim's model, you're going to break it up into 8ths.
Good. And how many equal parts is that?
8.
Good. 8 equal parts. Let's see if I can do this as evenly as possible. Okay. And
for John's model, you would make it into 4ths.
Okay. And how many equal parts is that?
4 equal parts.
Okay. And how much of Tim's bottle am I going to fill up?
2/8.
2/8, so 2 parts.
Yeah.
And how much of John's bottle am I going to fill up?
1/4.
Okay, so are the two fractions equivalent?
Yes, they are.
And why?
Yes, they are because they have the same size part filled with water.
Good, they have the same amount of water in it. The parts aren't the same size, but when you compare the two parts out of 8 and 1 part out of 4, you have the same amount. So yes, they are equivalent. Okay, we can also take a look at our fraction strips and look for 2/8 and 1/4, and you will see that they are in fact the same amount of space or the same size. Okay, boys and girls, those fraction strips, if you haven't seen the video, please go on over to Instagram, or I'll post the video in Class Dojo. But you can make your own fraction strips at home. They're super easy and they come in really, really convenient. So I'll post those for you. Okay, boys and girls, so today's Nearpod codes are on your screen. Please make sure that when you go to Nearpod, you answer the question completely. It's a collaborative board. And it's also going to ask you for your code word for today, which was bunny, okay? So the Nearpod codes in English are SAZOK. Em português, o código é SJWGR. En español, el código es COPVI, all right? And a message from Tyler.
Don't forget to like and subscribe.
All right, boys and girls, see you tomorrow.
Bye.
Bye.